Just write down number 2 for me. But before you do that, let me just read out the question. A spherical balloon of volume V is equal to 4 and 3 pi r cubed. So that's the volume of a sphere. That's the formula for the volume of a sphere. Just please note, just like this one here, they did not give us the area of a square, right? We needed to know that beforehand. In this one, they actually gave you the volume of a sphere. But that's not always the case, right? Sometimes you might be required to know this formula offhand, because they might have just said a spherical balloon is being filled with water at a rate of 200 cm cubed per second. And that's when you would be required to know this formula, beforehand. So just know this, right? You see a sphere, cylinder, square. Well, not volume or square, right? It would be like a cuboid. Just make sure you know those formulae, right? Because they don't always give it to you. Anyway, a spherical balloon of volume V is equal to 4 and 3 pi r cubed is filled with air at a rate of 200 cm cubed per second. Calculate in terms of pi, very important. So if you don't write your answer in terms of pi, that's like 1 or 2 marks lost already, right? For your final answer. The rate at which the radius, calculate in terms of pi, the rate at which the radius is increasing when the radius of the balloon is 10 centimeters. So just write that down for me, and then we'll go through it. Now, let me repeat that again. At a rate of, the minute you see that phrase, you know you're dealing with a rates question, and you need to note these 3 things. Okay, the first thing you need to do, need to note, wherever you see at a rate of, that means with respect to time. If it's with respect to time, then it's over dt. It's d something, whatever quantity they ask you for, over dt. So this first line here, they told me that the volume of this balloon is being filled with air at a rate of 200 centimeters cubed per second. At a rate of implies that it's over dt. But what quantity are they talking about? They're talking about volume. So it's dv on dt that they're talking about. Next thing, chain rule. dy on dx is equal to dy on du times du on dx. So let me just go to the black screen to do that one. So we know the first thing, dv on dt, and they told me that's equal to 200 centimeters cubed per second, right? So the second thing is using the chain rule. So modifying the chain rule a bit to get what you want, right? And the chain rule is dy on dx is equal to dy on du times du on dx. So I'm going to modify this rule to get what I want. What did they ask me for? Can anybody tell me what they asked for? What am I putting here? What symbol am I putting here? Okay, so they asked for the rate of change of R. So how would I represent that using symbols? Yes, dr and dt. How do I know that? Well, rate of change of R. Rate of change of R. When I see rate, I know it's on dt. dt. And what quantity did they ask me for? So let's just say it's the radius, right? Let's use R to represent the radius. So how can I modify this chain rule here to get what I want, which is dr on dt? Well, I know the dr has to come on top here. I don't know what needs to be at the bottom. And I also know that they gave me this right here, dv on dt. So what should come here in order for these two things to cancel out and give me the dr and dt? What should I write here? dv, right? Just a way to remember it. These two should, in a sense, cancel to give me what I want, which is dr on dt. So now that I have this, I know that I have this already, right? They gave me this. So what I need to do is that I need to find this right here in order to find dr and dt. What's the third thing I told you to look out for? Is the formula. What formula do you have to use? Well, I know they're talking about volume, so it's between area and volume, right? In this case, they're asking me about volume. Volume of what shape? A sphere. And what's the formula for volume of a sphere? Well, it's V is equal to 4 on 3 pi r cubed. In this question, they gave it to you, right? They actually gave you the formula. But like I said, that doesn't always happen, right? So just make sure you know this. Right. So what can this help me find? This formula. How can I use that to, find what I want? Well, I can actually find dv on dr. That would be, using my rule, this 3 would come over multiplied by 4 on 3 pi, and we know by the basic rule of differentiation, this 3 would become a 2 because I subtract 1 from the power. So that's r squared, that's a 2. Let me just simplify this a bit. So I would actually get dv on dr is 4 pi r squared. But there's a problem. This is dv on dr. So I had no problem finding that, right? It's 4 pi r squared. But that's not what I want. I want dr on dv. So what exactly do I do? Anybody has any ideas? I have dv on dr, but I want dr on dv. What to do? Put it under 1. Yes, that's correct. So just in case anybody didn't pick it up, the relation between dv dr and dr dv. This is why it's important to know like the foundation of math before you go on to more advanced topics, right? Because you're required to know this is not on your syllabus, this is just what you learn in, I don't know, primary school. That dr on dv is actually the same as saying 1 divided by dv on dr. And of course, you put back your dv and dt, right? Because, that didn't change. In case anybody's not seeing this relation, how this is the same as this, let me just write it in blue over here. We know, so this 1 divided by dv on dr. Let me just rewrite it like this: 1 divided by dv on dr. From primary school, in primary school, you learned that when you're dividing by fractions, it's the same as multiplying by the reciprocal of the fraction. And what do I mean by reciprocal? Well, we know that's when you flip the fraction, right? So this denominator will become the numerator, and the numerator will become the denominator. So saying 1 divided by dv on dr is actually the same as saying 1 multiplied by dr on d, well, that's a d, right? Anyways, dr and dv, and 1 by anything is itself, right? So that's why I could say 1 divided by dv on dr is actually the same as saying dr and dv. Do you understand that, or would you like me to repeat it? You can go on. Oh, repeat. Okay, repeat from which part? Sure, you need to tell me which part I need to repeat from. This, the relation between this and this? Yes. Okay. I just found, using the formula for the volume, I found dV on dr. But according to this right here, this equation right here, in order to find dr and dt, I need dr and dv and dv and dt. I have this. They gave me this. They said it was 200. I don't have this. I actually have dv on dr instead of dr on dv. So that's a problem, right? Because I need to find this in order to get this. So how exactly can I do that? Well, the relationship between this and this is that dr and dv is actually the same as saying 1 divided by dv on dr. But how exactly are they the same? Well, from primary school, when you were learning about dividing by fractions and all that, saying 1 divided by, okay, let me not use dv and dr. Let me use 4 and 3. If I told you to find the value of 1 divided by 4 and 3, we know from primary school, when dividing by a fraction, it's the same as multiplying by the reciprocal. The reciprocal meaning the flip of the fraction, right? So saying 1 divided by 3/4 is the same as saying 1 multiplied by 4 on 3. Do you understand that? Looking at this blue part here. This is what we're focusing on. Do you understand that, Troy? Oh, yes, okay. And then if I wanted to simplify, yeah. So if I wanted to simplify this even more, 1 multiplied by 4 and 3, what's the answer? What's 1 multiplied by 4/3? Troy, what's the answer? 1 multiplied by 4/3.
4/3.
Yeah, because anything multiplied by 1 is itself. So all I'm doing now is replacing that 3/4 on top here with dv on dr. That's all I'm doing, right? So now I have 1 divided by dv on dr instead of 3/4, right? So just like we did with the 3/4, we said 1 divided by 3/4 is the same as 1 multiplied by the flip of the fraction, so 4 and 3. Same thing we're doing here. 1 divided by dv on dr is the same as saying 1 multiplied by the flip of that fraction, which is what? What's the flip of this fraction?
dr over dv.
dr over dv. And what's 1 multiplied by anything?
It's still, we're about the same answer.
Yeah, so this would be dr and dv. That's why I can say 1 divided by dv on dr. So this is just another way of writing it. It's the same as saying dr and dv. Do you understand now?
Yes, please.
Nice. Right. So now I can actually use this, okay? So let me use blue again. So dv on dt, which is what I want to find, not dv, that's a r. dr and dt, which is what I want to find, would be 1 divided by 4 pi r squared multiplied by dv on dt. They told me that this is 200. So there was no need for me to go calculate that, right? They actually told me that at the beginning. All you do now, simplify. Can anybody tell me what I would get when I simplify this?
I don't have a calculator with me, so I can't work.
Yeah, that's fine. What's 4 into 200?
50.
50. So this would be 50 on pi r
Wait, you
squared.
still want the calculator?
Huh?
I thought in the calculator, but
Okay. Just remember that the question asks you for the answer in terms of pi. Eh? So that's why I left it as 50 on pi r squared instead of actually finding the decimal for 50 divided by pi, right? But we don't leave our answer like that. Why? Because they asked us for the value of dr and dt, so the rate of increase of the radius, when r is 10 centimeters. So they want the answer for this, the value for this, when this value of r is 10 centimeters. So what does that mean? Now I need to substitute this value into this expression right here to find the value of dr and dt. So what would I say? This is equal to 50 on pi by 10 squared. 10 squared is 100. 50 divided by 100 is a half, right? So my final answer is a half pi centimeters. Let me just put the per second here, per second. Why centimeters per second? Because it's the rate of increase, well, the rate of change of the radius. So radius is in centimeters, time is in seconds. So that's centimeters per second. Do you understand that? If there's anything you're unclear about,
Yes,
please just let me know. Okay, that's one person. What about the others? Are you clear on how we got this answer? This is the answer. Okay. Yes. Okay, nice. Well, time for you to try the other question by yourself. So because this is a rate question, how do I know that? Because I see this right here at a rate of. So I know one time I need to find out these three things. This, and this. Rate, yeah, this, and this. Because it's a rate question that I'm dealing with, right? One more thing I want to tell you. We dealing with volume. So remember on your syllabus, when doing rates questions, it's kinematics, volume, or area they could ask you for, right? In this case, it's volume. Volume of what shape? It's a cylindrical container, so it's a cylinder. And they actually gave you the formula here, so you didn't have to, know that beforehand. In terms of pi, don't forget that. Okay, you try now. And probably you should have recorded what I was just saying. But anyways, let me just read the question one more time. Water is poured into a cylindrical container of radius 5 centimeters. The height of the water increases at a rate of 2 centimeters per second at a rate of. Given that the formula for the volume of a cylinder is pi r squared h, like I said, they don't always give this to you, so please know this formula because it's very common for them to bring a cylinder, sphere, square, maybe a cuboid. Yep. Determine the rate of increase of the volume of the water in the container in terms of pi. This is very important because if you don't write it in terms of pi, you can lose up to 2 marks just because your final answer isn't in terms of pi. Okay, so you don't want to lose those marks. Right. We said when you're doing rates questions, there are 3 different things you need to note. So the first one, wherever you see rate, at a rate of, it's automatically on dt, right? Because rate means with respect to time. So just reading this first question, this second sentence, the height of the water increases at a rate of 2 centimeters per second. The height increases at a rate of that. So using h as the symbol in this case for the height, it would be dh on dt to represent that right here. And it will be 2 centimeters, right, per second. Next step is manipulating this chain rule to get what you want. What exactly do you want? Well, they ask you to find the rate of increase of the volume rate. So it's automatically on dt. And what quantity are they talking about? They're talking about volume. So what I'm really trying to find, or what is my dy on dx in this case, would be dv on dt, because that's what I'm trying to find. The rate of increase of the volume. Rate, meaning with respect to time, so that's on dt. And then what quantity are they talking about? Volume. So that's why it's dv on dt. Yeah? I really hope this is making sense to you. What was there? I just said dh on dt, where h is my symbol for the height, is 2. They told me that, 2 centimeters per second. Then the second step is to manipulate the chain rule to get what you want. So I will write the chain rule again, just to make sure that you're following what I am doing. So that's dy on du times du on tx. We already know that what they want me to find is dv on dt. That's what I was talking about just now, right? So this would be dv on dt. But now we need an expression for dv on dt. Well, I know if I manipulate this rule to get what I want, I know this numerator needs to be the dv. And then I know this right here would be the dh on dt. What would I put down here? Well, I need to put dh. Why? Because just remember the little trick I told you on how to remember the order. This denominator and this numerator should cancel to give you the dv on dt. Like I said, they don't actually cancel, and that's just to help you remember. Right. So in order to find what they asked me for, which is the dv on dt, I forgot about, yeah, be careful with that, eh? Always remember your substitution. I know it's common for people to forget that, and it's a new trick there. Yeah. All right. Back to what I was saying. We want dv on dt. We have dh on dt. That's the 2, but we need this. How do you find dv on dh? That's where the third thing comes in. What are they talking about in this case? Is it area or is it volume? We already know it's volume. Okay. Volume of what shape? Volume of a cylinder. What's the form? Is it volume? Yes. What's the wait, was it volume? Yes, it was volume. What's the volume of a cylinder? What's the formula for that? It's V is equal to pi r squared h. So using this formula, I can actually find dv on dh. Is the rate of change of V volume with respect to h. With respect to h. Very important. dh with respect to h. What does that mean? The only variable I am allowed to manipulate in this expression right here is this h. I cannot touch the pi. I cannot touch the r. I could only manipulate this h because I am differentiating with respect to h. Okay? Please remember that. Do not go saying manipulating this 2 and then you end up with the 2r and yeah, no. Just manipulate the h alone, right? That's all you're allowed to touch in this case. Right. So apply my rule. Hold on. So anything we're not differentiating in terms of gets left. So anything we're not differentiating. So anything we're not differentiating in terms of gets. I think I understand what you're saying. What's yes, because I think I understand what you're saying. So so I'm leaving this, right? I'm leaving the pi, I'm leaving the r squared, I'm only manipulating this h. And when I do that, I would end up with pi r squared, because in this case, the h is almost like a constant. The power is 1, so you carry across the 1. 1 minus 1 is 0. Anything to the power of 0 is 1. So I just end up with the pi r squared. If anybody wants me to go through that slowly, please let me know. Let me just use the eraser. Right, so I have everything I need to find dv and dt. dv and dt